Hi guys, I wanted to do a video on the soldering equipment that I have acquired in recent times and what my experience with it has been. I started to do this video and was discussing several of these components I got laying around here, and then I wanted to follow that up with some actual experiences, how I was going to use it. But in doing so, I realized that I still had some stuff to learn, and I had to redo this video about 3 times to update it. In the late 70s and early 80s, it was basically like this. This is a Fluke multimeter main board that of a multimeter that I actually bought in about 1978 probably. And as you can see, at that time, when I was working in the industry, it was quite different than today. There is a socket that's 40 pin CPU there. Let me get rid of the text here. And all the components are two true hole components on this PCB. It's a double-sided PCB. That's all, not multiple layers like today. The transistors are standard transistors, you know, with little legs on them, and they're soldered in. These chips here are standard dip packages. Capacitors and the resistors are all standard components, you know, with that are soldered onto the PCB with little legs on them and stuff like that. And these are tantalum capacitors. These things used to fail a lot in their day. So working on these kind of circuits, on the other side, that's where you can desolder them, and it was easy enough to work on. I've already removed a few components of this board that I've used somewhere else. Today, these circuit boards are much different. Like here is an example. See if I can get it a bit closer. Here's an example. These are, you know, capacitors, resistors. Some of them are small as a grain of sand. These are capacitors. They're all surface mount components. The little chips here are not dip packages. They are very small with little legs on them that are like, you know, 0.1 millimeter apart or something like that. They're very close together. On the other side, you will see there's a microcontroller on here. It's like a microprocessor in the old days, which is much smaller and much denser. So you need different equipment to work on stuff like that. And that's why I've been buying new equipment in order to make it possible to work on those things. And this is some of the equipment that I have. This is like a solder gun. It's like 100 watts, and you just push the trigger here and it heats up immediately. And I occasionally use this if I have to solder very thick wires or something that needs a lot of heat. And not very often, but you know, it just occasionally. The standard soldering irons don't have enough power. Then the next thing is to work with these surface mount components. Might as well discuss these tweezers over here. These are hot tweezers that you can use in order to you know, go into the circuit board, and you know, we will try this out in a minute and see what happens. You go on the circuit board and you can heat up both sides of the little surface mount components and then lift them off the board. In some cases it is possible to actually use it to resolder the components as well, but it's very tricky to use because yeah, usually often you have to use a little bit of flux and so on, and that's sticky stuff, and it's some of the really small components, they will just glue themselves to the, they stick to capillary action or whatever it is to the little tips there. This one here is actually a very cheap one. It's like $20 or something, and it's directly powered by the mains power, and it's got like, it's basically two 24-watt soldering irons with these little bladed tips on there. I found that some of these things from China, they are not great, well designed. This particular one here, you might just be able to see it there. There's like a little ridge there, and then there's like a little socket that fits into when you squeeze it together. And I found that was badly designed. This little this ridge here was too high, and when you squeezed it together, the tips were still that far apart, and then you had to really squeeze hard, actually bend the little plastic handles a little bit in order to get them to close up better. And that was, I had to actually open this up, and I took a file and filed it down until I can actually comfortably sort of squeeze it together and make the tips come together. And as soon as I did that, they started working. But these are, you have to be careful. This gets all really hot, and if your finger sort of moves to there, then you burn your fingers and stuff, and then not really recommended for that. But in some ways, so I bought these more expensive ones here, which actually has a temperature control. You can turn it on and off, and you can set the temperature on here and stuff like that. But in some ways, these actually work better than these. The reason being that these came with these tips here are very long and skinny, and if you're trying to desolder something that needs a lot of heat, that board I just showed you, that blue one, actually has a ground plane on one side and a power plane on the other, and the little capacitors on there invariably are connected either to the ground plane or to that power plane, and one side of it, soaks up so much heat that it makes it very difficult to remove them. Standard circuit boards, that have components connected to little traces and everything, either one of those will actually work. But these ones here, as I said, there's a limit to the conductivity of the heat. They also are in fact the same. They've got two little soldering irons. It actually has a little bit less power than the other one. This is 44 watts, that's 48 watts in total between the two of them. And another thing that was wrong with these is these tips over here were actually round, and so when you try to pick up a little component with it, or hold it, or even heat it, there was limited contact between the component and these tips, because they're round, and if the component is very small, then these would be touching the PCB, but then the little component wasn't making a good contact, so they weren't working very well. So what I've had to do is I took these tips out, and I took a little hammer and a tiny little anvil and a magnifying glass, and I actually tapped them until they are now square, and now they work a lot better. They're kind of usable in some cases. Nevertheless, as I said, they still have limitations, and the tips are still very small. I don't recommend these either. I'm going to be looking for better ones. I've been watching some of the videos on the YouTube where people do repairs, and they are use these things professionally. They seem to have better ones where the tips are like that. They can just touch down onto the, they are curved. I must have a look if I can find some of those and try those out, and I'll let you guys know if I do find them. So this is the hot tweezers. I thought I would interject over here. The sort of thing I'm talking about is this over here, and those are the kind of tweezers that I would like to get. But then I started to have a look on the internet, and this is kind of what I found. Very little actually, but this is what I found. Okay, so I put in hot tweezers for soldering. Let's have a look what we can find. Now on the other side here there is some images. And look at those prices. This looks like the sort of thing that he was using. Apex Tool Group, $348. Let's try this, check this out. Looks like that is just the actual little tweezers. I mean, $350 for a pair of tweezers. I mean, this is crazy. Totally absurd. Well, hobby use anyway. Maybe if you're in a professional shop and you're making lots of money, maybe you would pay that. And even then you'd have to buy probably a $500 soldering station with it or more, who knows. So that's not going to work. So I did a search on AliExpress for hot soldering tweezers, and as you can see, these are the ones that I actually got, and I hate that when they do that. I tend to not buy from stores to do that. Like I got $9.03 trying to suck you into clicking on that thing, but it is probably a little heating element or something like that, and when you go in there it'll be more expensive. But in any case, here is the one here for $24.80, and it is a lot cheaper than, of course, than on Amazon. The cheapest one was $58 there for exactly the same thing. But these are the ones I have, and I'm not happy with those. These ones over here, I'm not going to do it. These are a little bit different. I wonder what they are like. Let's click on it and see what they're all about. But they obviously need some sort of soldering station. Soldering station, hot tweezer, BGAs, and repairing. They actually look a little bit more promising. The tips are shorter. I've done a video recently on this soldering station here, which I built up from a little kit. There's not much building up. You've got to solder up the socket onto the wire and a few little wires inside and everything. It's not as though you have to do anything on the like construct a PCB or anything. But I love these things. These things are totally my favorite soldering stations. I actually have two of them. There's another one down there, which is slightly different. It has a metal case. It's was a bit more expensive. Looks a bit fancier, but they're both the same in performance. And one feature I really like about these things is, as I mentioned in the other video when I was using it, and I showed how it works. I got this. It just has one simple control here. You can set the temperature, and it goes up in 10 degrees C, but you can actually configure that. You can hold down the button, and there's like 10 or 12 settings you can change, but I don't tend to change them at all. I'll leave it as it is because it works perfectly for me as it is. Simply set the temperature over here, and if you push this button over here, you'll see it starts, this little light starts flashing, and it goes up about an extra about 20 degrees or something, 15-20 degrees, and it says, you know, turn it off already for like 10 seconds or something. It gives you a bit of extra heat. If you don't touch the soldering iron, it will reduce its temperature to 200 for a little while, and then it will actually reduce the temperature to 0. But there is a I'm going to turn this off. There is a sensor in the soldering irons that knows when you pick it up, and then sends a signal to the controller, and it actually automatically turns the power back on, and it it heats up within seconds. So it is a very nice feature. So I really like these things. They work for me. They can produce up to 72 watts, so they can usually do just about any soldering for me. And I have these are T12 tips, and they are relatively cheap. For about $20 or $30 you can buy like a whole kit of them. And I made a little 3D printed stand for them. This is my soldering equipment. It's got some brushes and things in there as well. But you can probably see I have a whole bunch of different tips, some really skinny ones, to these flat bladed ones, and then there is these bent ones. There's a couple of those in there. They are often used for the little surface mount components, and those little chips with all the pins. You can drag solder them. So that's what I like about this T12 soldering. And also you can get soldering irons. They're not all like that. The ones that come with these things are different. You got to unscrew them. But you can buy these soldering pencils. The tips, they just plug in and out. There's no unscrewing, there's no messing around, and that is very handy. Sometimes if you've got to change a tip, you can do it very quickly. It just takes seconds. So that's the little soldering stations that I use now. I have another one that I were using for a couple of years, but I like these so much that the other one is retired now. It's bigger and it looks more fancy, but these are better. Then we have some battery powered things that you can stick in your kit when you have to go outside where there's no power or something like that. This little kit came with a USB charger, and that's over there. It has a little stand, tiny little sponge in there. Strange enough, it works. Once you wet it, it seems to stick there, and you can just wipe it over there. And it sort of stands up in there like so. And you just push the button over here, like so, and as you can see, there's a little red light there, and as soon as that light goes green, it is ready for soldering. Doesn't take very long, and you can stick it in, and it has a light on it as well, so when you're soldering you can see what you're doing. It has a lithium ion cell in there. See, it's gone green, so it's ready. I'm going to turn it off because I'm not going to use it right now. It has a USB-C port there. Of course, it came with a little charger. You can charge it up. So that's another thing that we have. And then I got this dinky little, I saw it on AliExpress, and it was relatively cheap, so I thought I would try it out just for the heck of it. This is a little, also a battery powered thing. Now these guys here tend to have somewhere between 8 and 15 watts power output, so they're not going to work on really heavy duty stuff. This one here, it has a strange little charger. You actually have to, this is where the tips normally go, you have to screw it in there like so, and then you can plug it in to a USB port charging. Came with 3 different tips. This is a little pointy one, a sort of a flat one, and a little chisel one, and they would screw into the top here like so. The only strange thing about it is that when you want to use it, you have to push this button 5 times, and then it becomes active, you could say, but it's not on, and you actually have to push this button for not more than 7 seconds at a time, otherwise it goes into shutdown mode. So you become the actual temperature controller. You have to keep pushing the button while you're using it, which is very inconvenient. It has a little adjustment here set for 4.8 volts, and the next step is 4.3 volts, 3.8 volts, 3.3 volts. But quite frankly, if it's not set to 4.8 volts, it doesn't produce enough heat for soldering, so, and even the instructions say just leave it on 4.8 volts. It does work, and later on we'll do some soldering with it, you'll see. This little pouch didn't come with it. I happen to have a little pouch laying around, so I put it in there. The black cube one did come with a pouch. Yeah, it's cooled off already. Put that in there. A couple of years ago, I bought a hot air and soldering station, and what I'm going to do is I'm going to change cameras so that we can look at it. Okay, so I've got a soldering station there that came with this heavy metal stand, and because it's got a sponge, it has some spare tips in there, and this is a soldering iron that came with it, but as I said, I never use these anymore, because you know, you have to unscrew this if you want to change tips, and then you would have to push another tip on there, and then you got to screw that back up again. So if you want to quickly change a tip or something like that because you need a bigger or smaller one, then those T12 tips are just superior for that. You can just slide them in and out. And it came with a this thing I would use occasionally. It came with a suction desoldering gun, but I do have other desoldering tools. I'm going to do a little video on those as well. I only use this if I have to do a whole bunch of components, or something with lots of little legs and things on it. I might use it, but the problem with these things is that for me anyway, you have to, after you use it, you got to kind of disassemble it. You might have to unclog the, make sure there's no solder left in the nozzle. There's a filter in here, and there's another filter on the actual device there that you got to clean out, and it's a lot of work. So I have other desoldering devices that I don't have to do that with, so therefore they lost favor because of that. The actual soldering station is right there, and the one thing that I do use all the time is the hot air gun. That's basically all that I use it for pretty much now. And so the hot air gun is on this side, and you can turn it on over there, and then you can you can set the temperature and use this control here to change the airflow. Now over here, as I said, there's another filter in there for the desoldering tool, and this socket over here both takes the soldering iron and the desoldering tool. So you continuously have to, if you were using the soldering iron on here, and you need to solder something and then solder it back up again, you have to keep on unplugging this and plugging another device in there, which is very inconvenient. This is interesting. Just as an interjection here, I found on Amazon here a UA 948-2, which is obviously a newer version of the soldering station that I have, that I bought from Circuit Specialists, and you can see it's exactly the same thing but a newer version of it. It has a different switch on the front, and it now has a separate connection for the soldering iron and the desoldering gun, which of course I was complaining about, like you have to swap back and forth, but it is exactly the same thing. So that actually shows you that this thing actually came from just a Chinese distributor, and they had their own name put on it. So it's good to know though what it is, because I don't think Circuit Specialist sells these anymore, and I should be able to get a maybe spare parts from them and stuff like that. So just as a matter of interest, I thought I'd put that in there. Okay, so let's talk about flux. These there's Rosin Flux. This is like a paste flux with rosin in it. As you can see, it is pretty much unused. I have another one like it. Occasionally I'll poke some wires in there, but I don't think this stuff is very good. I don't tend to use it. Then there is some other Rosin Flux. I do use that. This some MG Chemicals. It works pretty good. Sometimes when I have some corroded wires, a little bit, you know, older wires with a little bit of corrosion on there and stuff, I will use this flux, and I have successful, it'll quickly solder, whereas sometimes, you know, it's hard to get the solder to take on older surfaces. So I do use this stuff for that. I do not use it on PCBs at all, ever. It's not the right stuff for that. For PCBs, like surface mount components and so on, and ICs, these are the fluxes that I use. I am fond of this one here. This particular one, you can find it at various times on eBay, AliExpress. I got this from AliExpress. It is also a paste, but it's not a rosin based paste. I don't believe, and it's a little bit. The other flux that is very common and that I use is this Amtech stuff. This Amtech stuff, there is a lot of fake stuff around. I think this is real, but I got it cheap because I think the expiry date is 12/21. And I think I bought it around about that time, so it was just about to expire. I think maybe that's why it was cheaper, but this stuff doesn't really go off. It'll work for a long time. This stuff here doesn't even have an expiry date at all. It is thicker than this kind of flux, and sometimes a little bit more sticky, and that's what you want. I use this for putting a little flux on the surface mount components and stuff at times, and I only just received this a new jar of this less than a week ago, so it hasn't been used much yet. I just poked a few things in there. So these are the two that I recommend. Is you've got to have some of this Amtech stuff, NC559, and this advanced quality is ZJ-18. I don't know if that means anything, but it says NT, and so that's that. Now this here is a special flux that you would use for if you got a solder to stainless steel and even aluminium, which otherwise is you can't solder to it. And in order to do that, I do also have a special solder here, which is kind of expensive. That's why there's only a little bit in there. And but sometimes if you have to solder something onto something stainless steel or aluminium, this is the stuff to use if the normal solder doesn't work. Sometimes the normal solder with this depends on the composition of the metal, it will still work. But you know, you have these battery pack, lithium ion battery packs, those little flat in like silver foil little pouches, and quite often they have a strip coming out of them that I think I might have an example over there. Let me have a quick look. Yeah, that's the sort of thing. It has it's a bit hard to see in this one because I got to put a whole bunch of hot glue on it to keep it together, but it had tags on there, 3 metal tags. I guess you can still see this one over here, and it's almost impossible to solder to when you try. And this flux, and in this case I use ordinary solder, but I use this flux over here. It actually helped to solder that together, and I think it has, when you use it, it kind of has a strong smell like hydrogen chlorides and hydrochloric acid. I think it has something like that. Now it is all Chinese on there, so I don't know what it says. I can't read that, but this is what I use. And the next thing, which is kind of crosses into the solders that we'll talk about next, this is solder paste. It's actually flux with tiny little grains of solder embedded in it, and of course you would use that for certain types of electronic components that you have to surface mount components, specifically when you have to reball one of those BGA chips and so on. This is the stuff to use. And then we've got solder. Solder obviously doesn't go off because this little lot here is left over from 40 years ago, 1978 or 9 maybe I bought this, and still works good. But when you're working with very small surface mount components nowadays, I use very fine solder, and here is one that's only 0.3 millimeters thick. And now this solder, I don't know if you can probably can't see that, but it is it says tin 60%, lead 40%. It has a tiny little bit of flux. It says 0.05%, must have some copper in there. Anyway, so that's leaded solder, which brings us to another story. This here is unleaded solder. I bought this accidentally. I was in a hurry one day. I wanted some 0.5 millimeter solder. I saw this in AliExpress. He got three of these for not very much money, so I said okay, send it to me. And when I got it, I realized that this is unleaded solder. It doesn't have any lead in it. So they come up with different alloys. Now when you buy these little soldering irons, sometimes you get a little bit of solder with it like this. This is also unleaded solder. It doesn't tell you that, but it is. You can tell because it's kind of stiff. And I think that people that manufacture soldering equipment and also when they send stuff from China, I think they have to include unleaded solder, and all the products, all the little, the PC boards and everything, they're all soldered with unleaded solder nowadays. So unleaded solder, I guess in the factory when they make these PCBs, they've got special ovens and conditions. It needs extra heat. I usually have to set the soldering iron to at least 400 degrees C in order for it to behave. Okay, just a little test here with leaded and unleaded solder to demonstrate the difference and why you wouldn't want to use it. Okay, so this is unleaded solder. Now I've got this, the temperature on the soldering station set to the temperature where normal leaded solder will work very nicely. And you see how what happens is I'm going to melt a bit more on there. This leaded solder is an alloy of several metals. I don't know exactly, this one doesn't say what it is, but it doesn't contain any lead. And what happens is that one of the metals in there is willing to melt at this temperature, and so it is, you know, it is becoming sort of fluid, but there is another metal in there which is just refusing to melt, so it becomes all grainy and strange. And of course, if you were making a solder joint like that, you'd probably end up with a bad solder joint, cold joint. Now here is some leaded solder, and you will immediately see the difference, see how it melts really nicely, and it dries with a very shiny surface like you would want. Now in order to get a better surface with this leaded solder, I'd have to go at least 100 degrees Celsius higher, which I'm going to turn it up now. I'm at I am at 120 degrees Celsius higher than before. And you see now it does melt better, but still for a little bit there it is shiny, but then as soon as you take the soldering iron away, you see how it becomes all dull and gray, and it is just unpleasant to work with. You need a lot more heat. It doesn't flow as well, and it is just for repairs and for hobby use, it is a disaster. This kind of unleaded solder is not something that you want to get involved with. In fact, we usually end up removing it when we're doing repairs and stuff, and we replace it with leaded solder because it just works so much better. So I thought I'd just do a little demo there what unleaded solder does. And as I said, for the unwary, when you buy little soldering irons, quite often you get I don't know if you can see this under the microscope. No, it's kind of too big, because it's you get a little tube of solder with it, and more often than not that is unleaded solder. And I'm just wondering if beginners, you know, buy soldering irons like that and they try to use that stuff, and it all ends up being a mess, and they decided they don't know how to solder or something like that. But it's not them, it's the solder that they've supplied with it. And just a heads up there, so you know what's going on. So let's now go and try some of the equipment out and look at some of the soldering techniques that we can use and what happens. Okay, so we're going to try out this little dinky battery powered pencil iron and see how that works, if it's usable at all. So let's have a look. So the plan is to put a little component on these little pads, and there's the little capacitor there that we will be intending to use. Now, in order to use this thing, the first thing you got to do is to push the button 5 times within 2 seconds, it says. and it flashes. Okay. And then the tip won't heat up until you hold down the button. So let's hold it down. And we're going to put a little bit of solder on one of those pads. Okay, it didn't melt the solder. I'm just going to put some solder just on one side for now, and take our little capacitor. I think it's a bit crooked. It's awkward that you got to push that, hold the button down. Oh, it's a tiny bit crooked, but I guess it's okay. And the reason I didn't put any solder on the other side is so that it lays flat. Oh, somehow it moved over out of the microscope. Okay, I think it worked for that sort of thing. It did come with several more tips. It also has this little flat tip, which might actually have been better for this, I'm not sure. And it's got this bigger tip over here, which is obviously too big for I don't know, maybe it's not too bad if you get used to it. So it did work, and now you're supposed to push it 5 times again. It flashes 3 times, and now it's supposed to be off. Okay, well, I guess where there's a will, there's a way. Now we've got some more pads over here, and we're going to try to put another little component on there. Let me see what we have. Here is another little capacitor. Alright, and what we're going to do now is we're going to try the other one. Switch camera so you can kind of see. We're going to try this one now. The black cube. This one only came with one tip, just a little pointy one. So I'm sure this one will work as well. Alright, so came with this little stand. Has a little sponge. You can put some water on there. Somehow it stays on there, this little sponge, so a little recess. Now this one, you don't have to hold any buttons down, you just push the button. And the red light comes on. And I believe it goes green when it's up to heat. or maybe not. I can't. Maybe it goes green when you are charging it. In any case, you can put it in this little stand, and we'll swatch. We'll go back to the microscope, and let's have a look. Oh yeah, it did go green. It went green, so that means it's up to heat. Oh, we're going to do this one, aren't we? I'm not putting any solder on there. I just want to make sure that it has a bit of leaded solder on there. Alright, tweezers. Let me see this little component. I think it needs to be the other way up. And these little things are tricky to work with, aren't they? Stick to your fingers, stick to the tweezers. Anyway, so this one is much easier to use. I don't have to hold the button down. It makes a difference. Is it still in view or not? Yeah, that's pretty much it. Yeah, it's much easier when you don't have to keep your finger on the little button. So I like this one a lot better, and it seems to have more mass, so it keeps its heats pretty good. So this one worked okay. Now turn it off. Got a little light in there as well, so it actually lights up what you are soldering. So I quite like this as a little portable unit that is not needs to be plugged into power. Okay, so that worked okay. Now I think that's pretty much it for those little soldering irons. Okay, so I've done some surgery to these hot tweezers. What I found was before, as I reported on that, there's this little guide here that stops the tweezers from, you know, having lateral movement, but it was too high. This section was too high, and it caused the tips to be about that far apart when it was locked. So you had to squeeze really hard and actually bend the plastic in the handles a little bit in order to get the tips to come together. So I've taken this thing into the workshop, and with a little chisel and a little file I removed a millimeter or two of the plastic there, and now it is working perfectly. So let's have a look what we can do with these cheap tweezers. Okay, now where is this component? Okay, that's the one there. All right, they are so small that they are truly hard to see in real life. Okay, I think that's pretty good. Alright, so that took it off. Pretty easy. And the only trouble is with over the flux on there, it actually sticks to the jaws. And goodness, this thing is so small. It's like a grain of sand almost. I mean, it's probably a millimeter long and less than a millimeter wide. It is doable though, isn't it? It's actually marked as L3 if I remember. See that correctly? This must be a little inductor. Okay, so that works well enough. I have taken to these tips with a little hammer. You can probably see I've flattened them off, so now that they're actually square, so that they will actually transfer more heat to the component, because when they're round, it's a little bit like that. I did a little drawing there, you see, so it doesn't make a good contact with the body. And these tips are round before, and also they would slip off, and you couldn't pick up components with it. They would just sort of slip out of the tips because they were round. So I flattened them off with a little hammer, made them square. Wasn't very hard to do, and they are much more effective now. Let's have a look what else is on there. Oh, here's a couple of big, also marked as L1 and L2. I actually want some of those little components to take them off. Oh, and okay, so that works pretty good now. So to put it back, solder it back, I would put a little bit of flux on there. Yeah, it's unleaded solder. Not giving up without a fight. Needs a lot more heat, you know, than the leaded solder. The first thing we always do is just clean off the unleaded solder, the crappy stuff. And then what I tend to do is I put a little bit of leaded solder on there, and the other one I don't put quite as much on, just touch. Hold it down with these other tweezers. Let's have a look. Yeah, that's solid. And then if need be, we can actually take the soldering iron and actually touch it up a little bit. So I didn't put quite as much solder on that side, so that needs a little bit more flux. Yeah, that's better. And again, if you need to take it off, it's easy enough. Now it's got leaded solder on there already. See, it's soldered back on again, so you can do it with the tweezers, but you do have to clean off that unleaded solder. Alright, so much for the hot tweezers. Okay, let's give these tweezers another shot. So turn them on, and I found that these are not ideal either. I'm still going to be looking for something better. The heat transfer between these tips here, they are too long and too narrow, and if you're trying to desolder a component that needs quite a lot of heat, it's just not able to produce enough. Besides, they're only 44 watts too, so however, on that I tried them on another PCB that had a ground plane on one side and a power plane on the other, and I just could not successfully. I could remove the component, put a little bit of flux on it, but putting them back was just almost impossible. So let's try this again here. What component are we? Yes, there's one there. Okay, it's up to temperature. Okay, so that came off pretty easy, but still, as you can see, it's hard with these tips, even though I squared them off a little bit to hold on to stuff. The other cheap ones, actually, it is easier with those to hold on to stuff. Little bit of flux there. Okay, so it is back, and so it is possible to remove and resolder these little components with these kind of tweezers, provided that they are not sort of stuck on a ground plane that needs lots of heat. I'm going to set this hot air down for 400 degrees Celsius. And of course, let's have a look. It is actually a heck of a lot easier than using those tweezers. Okay, see, that's pretty easy. You can't really do without a hot air gun nowadays for those things. Alright, so let's have a look what we've got. only thing that will happen is for the hot air, because the other two little components got blown away. Let's get a little bit of flux on there. I'll use some of this paste flux, that stuff. See how that works. Still warm, so it's melting. Okay. Just want to get rid of the unleaded solder on there. Now we can coat those little pads with some leaded solder. Where did it go? Okay, nice and shiny. Let me take these little components away, because we'll be blowing them away otherwise with the hot air. Got the hot air gun at about 50%. I think I can probably do a little bit less. 40% air. So let's snag one of these guys here. Yep, that's on. Okay. The thing actually looks bad underneath the microscope, doesn't it? It's got a crack in it or something. Okay, there it came off. Bit of flux. Alright, so that's back on. And so the hot air is probably a little easier because you can hold on to it with little tweezers like that. and then you can actually remove the tweezers, and provided you don't have the air up too high, you can just let it sort of settle into its the surface tension of the solder will pull it in. However, when you do that with hot air, you have to be careful, because when you heat that whole area, there are other components around it, especially if it is a PCB that needs a lot of heat because of the ground planes or whatever is underneath the component. You are liable to blow away with the hot air little components that are next to it, and makes a real mess. Anyway, that's hot air. So what have we learned during this soldering session? With regard to SMD components, surface mounted components, you can actually desolder them and solder them with various devices such as these tweezers and hot air and what have you. But they all have their limitations. If you're using hot air, you got to be careful that you're not overheating components around them. Some components can be heat sensitive. They can be plastic connectors that could melt. There could be electrolytic capacitors that cannot stand too much heat. And there could be little components around them that could be blown away by a hot air gun. So you might have to take action against, if you're using hot air, against heat getting onto places where you don't want heat to get to. You might have to heat it from below on the other side of the circuit board, or you might have to put some protective material around it, or on components, silicone pads and so on. So in those cases it is probably better to use something like these tweezers here. But as you've seen, both of these tweezers came with limitations that I had to do some surgery on them, on these ones, in order so that they would close properly. And these here, I found the round pins on those to be a real problem, because you couldn't squeeze hard enough on the components, which is sometimes necessary, and they weren't making a good contact because they were round. If the components were fairly flat close to the PCB, you would end up heating the top of the component more than the bottom, and that just wouldn't come off sometimes. And if you try to pick a component up with them, it would not hold between these round pins. So I've had to take to them with a little hammer and square them off a bit, which helped a lot. Nevertheless, I'm not satisfied with either one of these, and as you've seen early in the video, I found some that actually looked better, that might actually plug into my old solder station, which is this one over here. I believe that might be compatible. I had a look at it. I've worked out what the pinout on this thing is, so when that one comes from AliExpress, it'll probably take a month or something to get here. I will try it out and I'll post another video on that, and it might be of interest. They look a lot better than what these two are. So that's basically it. The information about the flux and everything is about right, and the solder, which you might have found interesting. So I will leave it at that for now, and I will be doing a video on desoldering and desoldering tools as well, coming up soon. And I am awaiting a new LCR meter, and we're going to be looking at what you can do with an LCR meter, and also some transistor testers and so on, that can also do capacitance and inductance, and see how they all compare. Now this channel, I'm doing this as for fun, as a hobby. I do not have some of the equipment that some of the other channels have, such as capacitors and resistors that are and voltages and what have you that are high accuracy that you can use in order to test multimeters and LCR meters and what have you, to see how accurate they are. I am more concerned with if they can measure very small values and large values and see what their performance is. So which for the average hobbyist is really all that is required anyway. A few microhenries here and there, or a few picofarads here and there, doesn't really make much difference when you're dealing with the sort of stuff that we are working with as hobbyists. Anyway, so goodbye, and I'll see you guys later.